This is a camera that was mounted. They're units 2, 3, and 4. By the time this picture was taken, Unit 1 had already exploded. And these pictures are at 1/300th of a second apart. So here we go. This is now you'll see on the fourth slide that's a flame front, and I calculated that the speed at which it grew, I could scale it off the building. I knew the size of the building, and I knew the duration of the single flame, that flame front was moving at around 1,000 miles an hour. And what that means, that's called a detonation. When something travels faster than the speed of sound, that's called a detonation. When it travels less than the speed of sound, it's a deflagration. Either one of them are going to hurt you, there's no doubt. The Challenger explosion technically was a deflagration, and we all know that was catastrophic. But this is worse because the wave front, just basically the pressure of the wave and the speed of the wave can do enormous damage. This is a problem on all reactors because no one knows why this happened. Hydrogen and oxygen at room pressures shouldn't detonate. I talked to a bunch of chemists, and we can't figure out how hydrogen and oxygen could detonate. It can deflagrate, like the Hindenburg, but it shouldn't be able to detonate. And that has major ramifications on containment design. Containments are not designed to take a detonation wave, and it can crack it. And I hope the NRC pays attention to that. Now, there are those who say that the perfect sphere might mean something. I'm not sure that an explosion like that would not. Why wouldn't it form a perfect sphere? But anyway, it's going up as a sphere. This is not a nuclear bomb. This is a chemical reaction, but clearly the amount of energy in it is pretty enormous. Okay. Now the rubble is pieces of the roof, but it's also nuclear fuel, and that's what's really frightening about this. They were able to find pieces of nuclear fuel about the size of my pinky. Almost nuked myself in the eye there. About the size of my pinky, over a mile away, between a mile and 2 miles away. And I calculated again how much energy it would take to throw something like that in air, which would have some air resistance. And even if it was a perfect sphere, which had very little air resistance, it still would have had to be thrown at around 1,000 miles an hour, which again it indicates that this was a detonation, not a deflagration. I think the nuclear industry is going to argue to downplay the significance of that, but the difference between a detonation and a deflagration is dramatic in containment design.